Yes. Good morning, all. So this is Reshma. Welcomes you to fourth session on database management system. So in this session, we'll discuss about three-tier architecture and the schema diagram, which is required for database design. So now in schema diagram, we'll point about some of the terms like the database schema. So now the database schema represents the description of the database. The description which is specified during the database design is referred to as database schema, and when the schema has been given, it is not expected to change frequently. And this database schema can be displayed in the form of a diagram, so that is referred to as a schema diagram. And each record or each object in the schema is referred to as a schema construct. So now the database schema, the schema diagram and the constructs are specified in the below diagram. So this represents a schema diagram for a student database. So it includes different objects, schema constructs like student, course, prerequisite, section and grade report. And this description will be specified during the database design. And if we see this schema diagram, so this displays only some aspects of the schema. So like it has displayed only the names of the records like student, course, prerequisite, section and grade point. And for each record, it has specified given only the data items. And sometimes it will specify only some constraints. But other aspects of this, other aspects will not be specified in the schema diagram. So other aspects means here the data type of each data item. What is the data type of name in the student table? What is the data type of class? Major. That is data type of each data item is not specified. And it also will not give the details about the relationship among these objects. That is most of the constraints are not specified in the schema diagram. It just gives the basic description of the database. So this is the schema diagram with their constructs and the objects and the data items. So the next terms we should know is about the data state or the snapshot. So after giving the description about the database, so we need to enter data in the database. Then the data at any particular moment of time is referred to as a state of the database, that is the database state or a snapshot of the database. And sometimes it is also called the current set or the current occurrences or an instance of a database. Then after entering the data, so we need to verify whether the data satisfies the constraints, whether it satisfies the constraints specified by the users, constraints specified in the database. So if the data satisfies the structure and constraints specified in the schema, then such a data set state or the snapshot is referred to as a valid state. So hence, specifying the correct schema to the database management system is very, very important. So we need to, whatever the schema we are designing, this must be designed with utmost care. More care should be taken while designing the schema, because according to the schema, the final database will be designed. And then, so the DBMS, sometimes it also referred to as the intention. Whatever the schema we are giving for the database, sometimes we can use the term the intention, and the database state we can call it as extension. So here we'll show some example, and at the beginning we said once a database schema has been described, so it is not expected to change frequently, but sometimes so if the data or the schema is not supporting according to the requirements of the users, occasionally it may require to change the schema of the database according to if the requirements of the users change, or during the evolution if they want to update some details to the database, if they want to add additional records or objects to the database. Sometimes it is required to change the description of the database. In such case, it is required to change the database schema, and the concept of changing the database schema is referred to as a schema evolution. And in most of the modern DBMS, it comes with a set of operations which are helpful for the schema evolution. So then once the data has been stored, the data which is stored in some storage locations, the description of the schema constructs, the description of the constraints which will be stored in a special location, and that is referred to as the metadata. So data of data, a data which stores the schema constructs and also the constraints is referred to as a metadata. So here we have a sample student record which stores the different data items of the student record, the data set which has been entered into the student record, and, and this is the snapshot. At this particular point of time, we can say the snapshot contains, or the database contains 5 records, and all records are having the value according to the constraints. So you can say this is a valid state of a student record. So once we know the meaning of the schema diagram, so how to enter the values, what are the details the schema diagram stores. So next we'll move towards the architecture of a database. In previous session we have discussed about characteristics of a database. So mainly we have discussed 4 important characteristics, like self-describing nature of the database, giving multiple views, providing the data storage, sharing of the data. So like this we have discussed some important characteristics of a database. So now to achieve those characteristics, so we have to design the architecture in the below format. So here the DBMS architecture, the schema architecture, it contains mainly 3 levels. So they are the internal level. So this internal level, it has the internal schema, and the internal schema will describe the physical storage structure of the database. So that is, it uses a physical data model, and it will describe the complete details of the data storage. Like what is the name of the data object, how many records available in the data objects, what is the name of a table, how many fields available, what is the data type of each field, which type of constraints are given for each field. That is the complete storage structure of a data item will be specified in the internal level. So it is called as an internal schema. Then in the second level of the tree schema architecture, so we are specifying the conceptual schema, the conceptual level, and this conceptual level has a conceptual schema, which means it describes just the structure of whole database, and that to be for the community of users. So it will give details to the users, means it will not give the internal structure, but it hides the details of the physical storage structure. It just concentrate on describing the entities, which are the entities available. Like if it is a college database, it will just tell entities available are student, faculty, course. So like this, it will just give the details of the entities. If it is a student, what are the fields like USN, name, semester, what are the data types, just what is the relationship between the data types, what operations we can perform. So it will just describe the conceptual structure by hiding the details of the storage. And always, so whenever the implementation of conceptual schema is done, this is based on the conceptual schema design, and that to be in high level data model. So this is about the second level of tree schema architecture. And the final level is the external level. We can also say this as a view level. So now if we go for the conceptual or view level, and as the name indicates here, this includes a number of external schemas or a number of users, and each user may be having their own view. So now if the database contains a large amount of data, each user may not be in need of the complete database. They may like to know only about some part of the database. Then in such cases, we can create a view of a database. That is, the view means this is just a virtual database, so it is not having any physical structure. That is here what happens here. For external schema, it describes just part of the database that a particular user is interested in, and it hides the rest of the database from the user group. For example, if you take banking database, in banking database, if you want to know about loan detail facility available in the banking database, so then you are the user who are interested to know about the loan facility, then it will create a view which stores information about the loan. It will display only information about the loan, and it will hide other details which are available in the database. And again, if you are account holder in that particular bank, then it will display the details related only to your account. You can see what is your account number, what is the balance available in your account, what are the last transaction done in your account. It will not display details of all other account holders, the balance available in all other account holders. No, it will hide the details of other viewers, the other complete database, and it will display only the information related to the particular user who are interested or who are viewing the database. So now in external level, we can have n number of users. So now we'll see the diagrammatical representation of the tree schema architecture. If I see this here, it shows the three levels. The first level here I have given, that is the physical layer. Physical layer is the internal level, which will give the physical representation data storage. Then above that we have conceptual layer. The conceptual layer, it will give the conceptual structure, it will just give the logical structure of the database. Then if you go for the external level, so that is external layout view for the end users. As we said, here it contains n number of viewers, n number of users. Each user can view the database according to his requirement. Here we have three viewers, users. First user will get the view 1, second user view 2, third user view 3. So each user will be having accessing the database for his purpose. So this is the diagrammatical representation. We can also define tree schema architecture like this. So now here, between each level, there will be mapping from a database, that is between internal level and conceptual level. So there is a mapping of conceptual and internal level mapping. Again, between conceptual level and external level, we can see external and conceptual level mapping. So now here, based on these mapping facilities, the tree schema architecture, it supports a special feature of DBMS that is called as data independence. So data independence is, this is the property of a special feature of the DBMS that helps to change database schema at one level without requiring to change the schema at the next level. So as we have seen three levels, internal, conceptual and external levels. If I have done any changes in one level, it should not affect, no need to change the schema at the next level. I'll change schema at internal level, no need to change at this conceptual level. If I have done some changes in the conceptual, again no need to do the same changes at the external level. So based on where we are doing the changes and where it is not affecting, based on that, data independence can be categorized as two types: logical data independence and physical data independence. So before seeing what changes we can do, we can see which are the different methods we are using in each level. If I go for internal level, as we are concentrating on the storage, there we can specify which are the different data structures which are used for storage, whether you are using arrays, are using the stacks, queues, whatever the data structure we are using, they will be specified here. We can make use of any data structure, but this will not affect our conceptual schema. Either you can use files or records. Initially, we may be making use of B plus trees to store the database, to store the content. Later, I will shift from B plus tree to linked list. Then I may move the data from hard disk to some CD, then CD, then I will move to some flash drive, then I will be moving to some floppy drive. So like this, I can change the storage devices also. Whatever the changes I am doing at the internal level, this should not required any changes to be done at the conceptual level. Similarly, at the conceptual level, to give the structure, sometimes I may be using the tables, relational model, sometimes I will be making use of ER model, or I may be making use of some object oriented model. Whatever the model you are using to represent the structure, this should not affect the users with the different views. So now based on that, we have logical data independence and physical data independence. So logical data independence means if you have done any changes between conceptual and above, that is external. Physical data independence, changing at the lower level, that is internal level, to the next conceptual level. So that is, we can see here, physical data independence. This is the capacity of the database architecture to change the internal schema, that is at the lower level, without having to change the conceptual schema. So means this helps you to separate conceptual level from physical levels. So it allows you to provide the logical description of the file without the need to specify physical structure You need not to worry about what is the physical structure, which type of data structure they have used. No need to worry about that. You can give your own logical description. Then whatever the changes done at each level will be absorbed between the conceptual and internal levels here. See, for example, so what are the different type of changes we can do at the internal level? So if I see some example here, in the internal level, assume that you have changed the storage device from the existing drive to the hard drive, or you will be storing the data. Earlier you might have stored the data in hard drive. Now you want to store the data in the magnetic tapes. So when you have stored the data in the hard drive, during that time you have given some logical structure at the conceptual level. So now I'll be changing hard drive to magnetic tapes. Even if I am changing the storage location, the whatever the logical structure I have given at the conceptual level, it remains same. Similarly, I will be modifying the file organization techniques in the database. Then also it will not affect the logical structure. I will be switching to different data structures. Instead of queues, I will use I will be going for arrays. Instead of arrays, I go for then linked list. I will go for different type of queues. Whatever the data structure you are using, the logical structure remains same. For example, for student, you have given a data type as string, which contains maximum of 10 characters. Whichever the data structure you are using, the data type for name remains a string. Similarly, if we change the access methods, if I change the indexes, if I use some compression techniques, so whatever the changes you are doing at physical level, at the internal level, like we are changing C from C drive to D drive, or changing the location, whatever the changes you do at the storage location, this will not affect our logical structure at the conceptual schema level. So this type of changes at one level and not affecting the upper level conceptual level is referred to as physical data independence. As the name indicates, we are changing the physical location, physical structure, but it will not affect our logical structure. So this is, if I take some simple example, being human, whether you are slim, whether you are fat, your body structure may be changing, physical structure may be changing, but your heart remains same. Your heart feelings, it will not change with your physical structure. That is called as your physical data independent of your physical structure, your feelings, your logical thinking, it should remain same. So like in last semester I was slim, so I have scored 50 marks. My logical thinking was good, but now I became fat. My logical structure will change? No, your logical thinking will remain same irrespective of your physical structure. So this is called as physical data independence. The next type of data independence is logical data independence. So this is between conceptual level and external level. So that is here. The logical data independence is the ability to change conceptual schema without changing the external views. Whatever the applications we are using at the external views, they will not change. See, for example, again, if I take banking database, earlier we are making use of internet banking to do the transactions. Okay, so now through the internet banking, I will be accessing the database. Assume that after some days, the bank has changed the structure, logical structure of the data. So for account numbers, initially they might have used data type as integer for 10 digits. So then they will change, instead of account number, they have to make use of different username and password. They have to use internet banking details. Internet banking account they have to use instead of directly the account number. Now the logical structure has been changed. Now if I try to access through the internet banking, will it affect whether the balance will change? No, it remains same. Now instead of internet banking, again assume that you will be making use of some Google Pay or any other applications you are making use. But even if you are using any other applications, even though the logical structure which they have used, whether they have used relational model or they are using the tables to store the data, or whether they are making use of object-oriented methodology to store the data. So whatever the logical structure they are using, this will not affect the viewers. So being a user, I am not aware about what type of logical structure the bank has been used to store our details. We are not aware of that. Simply, I want to get the details, I can extract the details. So that is the logical data independence. That is, the users are independent of the changes in the logical structure at the conceptual level. So that is, if they made any changes, this will be absorbed between external and conceptual levels. So now, but if we compare our physical data independence and logical data independence, so our logical data independence is little bit complex, it is challenging. So we'll see some examples where this logical data independence is applied. So now if we see, due to logical data independence, so any of the changes which we are doing will not affect at the external level. So like I'll be adding or modify or delete new attribute initially for the banking database for a particular customer. They have maintained the details like customer name, customer address, customer phone number. Now after, so then if I try to access the data, whatever the data required about my banking details, my account number, balance will be given to the users. So now again they were changing the structure of the customer. So now they are adding the PAN number. After adding the PAN number, if the user try to access their data, then also they will get the data. Now again they are adding the Aadhaar card number. So that is the structure of the account holder is changing by adding or modifying or deleting the new attributes, the new columns to that particular customer, to that particular entity. But after adding additional details to that particular account holder, we need not to change the Google application which we are using. So I may be using Google Pay to access my database, banking database. If they remove some column from my account, if they remove my PAN number details from the account in the bank system, in the conceptual design, do I require to change my Google Pay details? Whether the Google Pay application will change? No. The Google Pay application will remain same even if the bank is changing the details of the account holder at any point of time through the logical structure. So it remains same, that is adding, modifying, deleting a new attribute or entity or any relationship between the entities, it will not affect the applications at the higher level or external level. The applications need not to be changed. If they merge two records into one, if they break an existing record into two or more, so whatever the changes they do at the conceptual level, so this will not affect the external level user views. So this is about the physical and logical data independence. Then what are the benefits? What are the importance of having this data independence? So there are a lot of benefits here. I will just highlight some. This will help to improve the quality of the data. No changes are required frequently between one level to another level, so this becomes affordable. So if there is an enforcement of standards and improvement in the database security, that can be done easily, and need not to alter the data structure in the application programs. If Google Pay app is designed with the help of a queue data structure, if there is any changes in the conceptual schema, so no need to change the data structure from queue to any other data structure. So no need to change the data structure in the application program. But if you are making use of the file system, we need to do the change of the data structure according to the application program, because in the same program they will be including both data structure and all. So like this, some of the importance of the data independence are listed here. So now here I would like to highlight the additional differences between logical data independence and physical data independence. This is the revision of whatever we have discussed till now. If you go for logical data independence, this concerned with just structure or the definition. But if you go for physical data independence, this concerned with the storage of the data. In logical data independence, it is difficult as retrieving the data is mainly dependent on the logical structure. To achieve this is to retrieve the data, it is difficult, but it is very easy in case of logical physical data independence. And to achieve logical data independence, this is somehow difficult compared to physical data independence. And here no need to change the application programs if new fields are added, deleted or modified in the database. And here any change in a physical level does not need changes at the application program level. Then in logical data independence, modification at logical level is significant. So whenever the logical structure of the database are changed. So but here modifications made at internal level may or may not need to improve the performance. And here logical data independence is concerned with the conceptual schema and this concerned with the internal schema. They are not worrying about the above schema levels, they will just worry about their level. Physical data independence at the internal schema level and logical data independence at conceptual data levels. So as we have discussed, what are the changes we can do at the conceptual level, or the changes at the conceptual level are either adding, modifying or deleting a new attribute, and this will not affect application programs at the external level. But if you go for physical data independence, change will be done in compression techniques, access techniques like hashing algorithms, different storage devices, different data structures can be changed at the internal level, but they will not affect at the conceptual level. So this is about physical data independence supported by 3 schema architecture in database. So thank you. In next session, so we will discuss about main differences between flat files, traditional flat files, and the current, the modern database management system, and different type of data models which are used for the storage. So thank you. To get the next sessions, please subscribe to this channel and keep updating. Thank you.